All right, so this is day 5 homework, and so I'm going to ask you to read question number 1. What is the equation of the function in factored form? Okay, so hopefully you are able to get to equation 1. Number 2, if any exist, identify the vertical asymptotes and then explain how you know that they are vertical asymptotes. Okay, so here we have, since x plus 2 is a non-canceling factor in the denominator, then x equals -2 is a vertical asymptote. Number 3, okay, so do we have any holes? Explain why or why not, and then what are the coordinates of the holes if they exist? All right, so we have, since x minus 2 cancels, the 0.254 is a hole. So again, how do we calculate that? Well, we reduce the function to just be x plus 3 over x plus 2, and you're replacing x with 2, and we get 5/4, so that way we can generate the point. Okay, go ahead and answer number 4. All right, so we are identifying horizontal asymptotes. Remember, the technique for identifying horizontal asymptotes has you look at the degree. So let's take a look. It says, since the degrees of the numerator and denominator are equal, then 1 over 1, right, the leading coefficient of the numerator divided by the leading coefficient of the denominator, y equals 1, is a horizontal asymptote. Okay, so what are the zeros of the function? Okay, so remember, in zeros of the function, it is going to be the other factor in the numerator that doesn't cancel out. And so you're setting that equal to 0 and solving for x. Then we can identify the domain and the range of the function, and we're going to give our answers in interval notation. So again, domain is everything except where there is a vertical asymptote in the x value of the whole. And then make sure you put it in proper numerical order. And then the range is all real numbers except where there's a horizontal asymptote or the y value of the whole, and you put that in numerical order. And then you're supposed to sketch a detailed graph. Okay. So one of the important situations here when you go to graph, you want to be able to pick points to the left of that vertical asymptote and also to the right of that vertical asymptote. And then pick some x values, plug them in, and then plot the y values. In this particular case, we had y equals 1. So let me go ahead and draw that horizontal asymptote right here so you could see that the graph is actually approaching 1. All right, so let's take a look at questions 8 through 14. So go ahead and answer those as they come up. Okay, on number 8, it says, what is the equation written in factored form? So hopefully you are able to identify those factors. Vertical asymptotes. Okay, so since x plus 3 is a non-canceling factor in the denominator, then x equals -3 is a vertical asymptote. Okay, any holes? Since x plus 1 cancels out, this is the point of the hole. Here's my work to get there. Identify any horizontal asymptotes. Well, we would have to again compare the degrees. Since the degrees of the numerator and denominator are equal, then we've got that leading coefficient, that reduced form, which is 3x plus 2 over x plus 3. So we've got 3 over 1, or y equals 3 is the horizontal asymptote. What are your zeros? Well, you're going to set that non-canceling factor equal to 0 and solve. Domain and range. Make sure that they are in numerical order. And then the detailed graph. So hopefully you are able to sketch a detailed graph, and I want you to check your work. Making sure that you have some of these points that I do. Okay. All right, 15 through 20, and then graph, and then let's check our work. All right, so 15, here's factored form. We have our vertical asymptotes at x equals 1 along with the proper explanation. We have our whole at 3, 1 with the work as well as the explanation. Horizontal asymptote along with the explanation. The zeros, there are no zeros. Pay attention here. This is interesting. When y equals 0 is a horizontal asymptote, there should not be any zeros because a 0 is where it crosses on that x-axis. And if y equals 0 is a horizontal asymptote, chances are we're not going to have any of those zeros. All right, domain and range. And then now let's take a look at number 21, making sure to identify some of those points. All right, so here we go. Let's take a look here. Here we have a graph, and then now we're going to kind of go backwards a little bit. So what can be said about the degree of the numerator compared to the degree of the denominator? Well, remember that the degrees of those are going to determine that horizontal asymptote. So we know that the horizontal asymptote is 1, so let's take a look at how we can explain that. Since f of x has a horizontal asymptote that is not on the x-axis, then the leading or the degrees of the numerator and denominator are equal. Okay. If a is a leading coefficient of the numerator and b is the leading coefficient of the denominator, what is the value of a over b? And then give a reason. And so here we know that since y equals 1, then the ratio of a over b needs to equal 1. Okay. So we can write that down. Number 24, what factors are guaranteed to be in your denominator, and then give a reason. Okay, so let's see if we can identify that vertical asymptote along with the x of the whole. Here's our explanation. Since f of x has discontinuities at x equals -1 and x equals 2, then x plus 1 and x minus 2 are factors in the denominator. Okay, what factor is guaranteed to be in the numerator and does not cancel out, and give a reason. Since x equals -4 is the 0, so again, that's the y-intercept, then x plus 4 is in, I'm not the y-intercept, the x-intercept, sorry, I misspoke. Then x plus 4 is in the numerator but not in the denominator. Okay, so this right here is the x-intercept. It's the 0. Okay. Number 26, what factor is guaranteed to be in both the numerator and the denominator, and give a reason? Well, we know that wholes appear in the numerator and the denominator. That's why they cancel out. So here's our explanation. Since x equals 2 is point discontinuity, then x minus 2 is a factor in both the numerator and the denominator. Number 27, what factor is guaranteed to be in the denominator that does not cancel out? Give a reason. And so here we know that x equals -1 is the vertical asymptote. Then x plus 1 is a non-canceling factor in the denominator. Number 28, in both factored and standard form, find the equation of f of x. Give 2 graphical reasons why your standard form equation makes sense based on the graph. So the first thing we need to do is be able to take all of the preceding information and put it in proper factored form. And then we need to multiply it out. And then once we do that, then we can kind of look at seeing if our horizontal asymptotes make sense as well as our y-intercepts. Let's take a look at number 1. The ratio of the leading coefficients 1 over 1 equals 1 and is the value of the horizontal asymptote y equals 1. Okay. Then condition number 2, or reason number 2, the ratio of the constant terms, which is -8 over -2 equals 4, and that is the y value of the y-intercept 0, 4.